another surprise presentation from one of the Blocks Hub teams. Please welcome to the stage the Modulo group. That way around. Yeah.
Hi, I'm James. I'm an architect from HD Lab in Copenhagen. And this is my team from the AEC Hackathon in Copenhagen last week. And we're going to present today our hack. So, there are many companies in the world creating prefabricated timber and modular components. However, there are many problems with this process that we need to overcome. These problems include that it is time-consuming for architects to consider the dimensions of the modules late in the design process. Estimations and analysis often lead to changes that cost more as the project goes on. And there are a lack of connections between different softwares and different professionals. We identified these problems when talking to CREE, a timber component manufacturer, and they said that when they're contacted by an architect, that it takes too long to adapt the architect's design to the CREE system. This is so that they can give an estimated price and check the design feasibility. We believe that if we can make this process more efficient, we can design more sustainable buildings. For example, with the CREE system, you can cut the use of concrete by 2/3 and CO2 emissions by 80%. So, we have leveraged the vast amount of Revit and other BIM components on BIMobject.com to create a modular building design generator that links a parametric model in Grasshopper with a user interface in Revit. This allows an architect to design sustainable buildings with ease. We call this software Modulo, and it allows you to automate the design of modular buildings, to perform analysis and estimations early in the design process, including cost, CO2 emissions, and environmental simulations. And it acts as a bridge between Revit and Rhino with a convenient user interface. We will now give a short demo of the software. So you open the modular window in Revit. You get a couple of parameters, such as the floor height, the number of floors. And when we're happy with our design, we can click Generate to create a Revit model with all the correct modular components. We can also design with different building topologies. Next, we will try the linear block, which has its own unique parameters, such as the building length in modules. And again, we generate a construction detail ready Revit model that would take an engineer at CREE about 2 to 3 days in a matter of seconds. We can also design slightly more complex building topologies. Here we have the perimeter block with a courtyard in the center. And as you can see, there are different sort of depths in the floor slab, different depths in the floor plate. And this involves different connections between the slabs and columns. And lastly, we have a more experimental freeform topology that creates angled building from a user-drawn line in Rhino, which uses custom CREE components, as you can see, the slabs in the dark gray, that would have to be specially ordered from the manufacturer. As you can see right here. Okay, so our hopes for Modulo are to further develop the script to include generative design algorithms such as performance-based optimization and building simulation, to integrate other modular manufacturers other than CREE, and to scale the software to the needs of the industry so we can work on real projects with Modulo. Thank you from me and all the team.
So again, another amazing example. You guys worked amazingly hard for the 48 hours. And yeah, so I hear that you guys are now going to start doing this project with CREE to carry it forward in the coming kind of years. It'd be really interesting to see where you guys take this.
Yeah.
So you've got big buy-in from them. And of course, you guys as manufacturers, you may see your BIM objects flying into this tool very, very soon to have all automated design. So again, guys, thank you very much. And we hope to see you at the Hackathon next year again. Thank you.
Thanks.